Okay, so for 5-3, the perpendicular and angle bisector theorems. First of all, for perpendicular bisector, we just think about what the word perpendicular means. Remember, it forms a 90-degree angle. Two lines intersect and form a 90-degree angle. That's what it means to be perpendicular. Bisector means it's to cut something into half, into two equal parts. And so our symbol for this is perpendicular bisector. Perpendicular sign cuts in half. So it cuts a side into two equal parts and forms a right angle. You may remember this from our isosceles triangle thing. It's very, very similar. So PM right here is the perpendicular bisector of AB. Now the difference here is this isn't trying to be a triangle. What this is saying is it's cutting this side in half, PM is, and then these distances are equidistant from point P. So it's really not trying to be a triangle. If you see it as a triangle, that's totally fine. But the main point is that this line PM cuts AB in half and forms a right angle. For angle bisector theorem, okay, same thing, angle getting cut in half. It cuts through the angle into two equal parts and is equidistant from the sides of the angle. And so we know that the shortest distance from a line to a point is going to be by forming a right angle. It's going to be going straight towards it. And so that's what we're doing here. When I say QS bisects PQR, it cuts this angle in half, okay? And then not only does it cut the angle in half, it's equidistant from each of these points, okay? So when we're going here, the fastest way to get from this point to this line is to go straight, and so it'll actually form a 90-degree angle as well. And so in this, the bisector is our shared side, the reflexive property. And we have two angles and another side. So we could prove this using angle, angle, side, or angle, angle, side. Both of these work to prove that these triangles are congruent, just like what we were doing up here with side, side, side. But we can use that to then solve problems, okay? So problems that you might end up solving on Math Excel might be like the two-column proof where you fill in definitions. But when we're just using the perpendicular bisector theorem, like down here, okay, we're just saying, hey, I know these are congruent. These two triangles are congruent because it's a perpendicular bisector. Perpendicular cuts the side in half. We could prove this using side angle, because that angle would be 90, side with reflexive property. So we know the triangles are congruent, and then congruent parts, corresponding parts of congruent triangles are congruent. So I know that these are equal. So I set them equal to each other. I solve for x. I plug it back in. So that one's very simple. And a lot of these are that same way. Because these triangles are congruent by angle, angle, side, angle, angle, side with reflexive property, I know that these two things are going to be equal because this is an angle bisector. So I set them equal to each other, solve for x, and plug x back in to figure out what the values are. So please keep that in mind. It doesn't matter which one you do, Math Excel, textbook problems, or the worksheet that I put on Canvas. They all pretty much do the same thing. Just know. I always get asked this question. According to the diagram, how far L is from HK? How far is L from HK? Well, that's how far L is from HK, that line right there. It gives it to us, okay? If you have any questions, please text me on Remind. And that's what 5-3, perpendicular and angle bisectors, is all about.